Yep. Cams on everyone. So this was the last thing that we did. Great. So let's go ahead with the question. So we have a wall here. The coefficient of friction is 0.2. We got a block here. We have one more block here. The two blocks, they are pushed against each other. This guy was 3 kg block. This guy is 2 kg block. And you're applying a force F. Gravity is there. And the friction between them, this friction is 0.3. The friction between the wall and the 3 kg is 0.2. So the question is, find the minimum force F so that none of the blocks slip. If there is no slipping at any surface. So there is a possibility if you don't apply enough force, maybe one block will be at rest and the other one will slide. Let's get this, everyone. How do we approach this?
हाँ
Step one, draw your FPD. Start from there. What else can we do? So if I draw the 2 kg FPD, let's see each one. So you are applying force F. This is the normal reaction N1. This is the weight 20. Till here, everyone knows how to draw FBD. Now you need to ask yourself, if there is no friction, what will happen to the 2 kg block? It will come down. So friction will be which way? Up. That's what I told you, right? This whole chapter is about finding the direction and the magnitude. So friction must be up. Should I write F max? I don't know. Are you sure it is slipping? We don't know, right? So we don't know. Done. So since it is not slipping, let's call this F1. So F1 is equal to 20 since it is at not slipping. Since it is not slipping, friction must be less than equal to mu into N1. So this should be 20 less than equal to, and we also know here F is equal to mu is 0.3 into F. So F must be greater than equal to 200 by 3. So this is saying if the force is greater than 200 by 3, 2 kg won't slip. Great. Now, if I draw the 3 kg FBD, this would be N1, and here F is equal to N1. This would be your N2. Now, by Newton's third law, if F1 is up here, F1 has to be down here. And obviously, F2 has to be up here. Someone has to keep the block at rest. So this is 30. Is everyone clear with the FBD? This is how you figure out the directions of friction. 2 kg mein F1 has to be up. There is no other option. If F1 is up here, F1 has to be down here. Newton's third law. Now, here the only one who is balancing. So N1 is equal to N2 is equal to F. So F2 is balancing F1 plus 30. But I already know F1 must be 20 because it is not slipping. So F2 is 50. Now understand one thing here. The friction is saying, you give me 50 newtons, I will make sure 3 kg won't slip. Isn't this what the meaning of the statement? Friction is saying, if you give me 50, I'll keep it in equilibrium. Matlab, this value must be less than equal to mu into N2. This value cannot be greater than whatever I can give you maximum. So this is 50 and mu is how much? 0.2. So this surface is 0.2 into F. So this is saying F must be greater than equal to 50 by 0.2. How much is that? 500, 250 newtons. So this is saying if 250 newtons, if you give me, 3 kg won't slip. Perfect. Now you don't want both of them to slip. So you tell me how much should I give? This 200 by 3 is roughly 166.66 newtons. So if I give 166, 2 kg won't slip, but 3 kg will slip. So you should give maximum of both of them, right? Therefore, the minimum force should be 250 so that both of them won't slip. What if I give 200? If I give 200, 2 kg won't slip, but 3 kg will slide, right? So they can ask questions like that also. If you can take 5 kg system, then how will you find F1?
Sir, for F2.
Maybe you can take. What is the use of it? Because you're getting the answer, that's why. What will you do? Suppose if this value was not 166 but 350, then how will you get the answer? So fine, na, for finding F2 you found, right? So what? That won't help you to get the answer. Is this clear, everyone? But F2 aa jayega, but then still you have to find F1. You still have to draw an FBD. It won't matter. Better you keep separate FBDs. Is this clear, everyone?
So, can we consider both the blocks to be like the one system and then calculate? Like, they are not
Isn't
moving,
that the
right?
same thing? So fine, then what will happen?
So, is that like, we can do that? Right?
You can do that, but usse fayda kya hua?
So only the friction on the, like, by that ground and gravity must
I got it.
equate
So
to
F2
be.
aa jayega. Then what?
Yes, so like that.
उससे कुछ फायदा नहीं है because for example you guys are saying that way because answer match हो रहा है. If this value had been 400 newtons, if you do that method you'll get 250, so you'll write 250 and come. You're
Yes.
supposed to compare, na? You need to compare both the conditions. If you draw, take the whole thing as one system, F2 आएगा, I agree, but you won't get this data point. Luckily in this problem this value became less than 250, so your answer is matching. Clear with that? You can try that. अगर try करना है ना, इसका 0.2 करो, इसको 0.3 करके check करो, आंसर पूरा मैसअप हो जाएगा. हाँ, so if you say I will do only for F2, आपको you have to draw this FBD.
So if the like is that like if the coefficient of friction for the below one is less than that of the smaller one,
ना, that's what I'm saying ना. Don't try to create a thing. You're trying to create a formula now. If this happens I will do this, if that happens I will do this. Exam में इतना guts होगा क्या? तो वही बोल रहा हूँ ना, let's not do anything which you won't do in the exam. See, simple na, 2 FBDs, bus. Even if you do that, what are you doing? You are drawing full FBD, then you're drawing this FBD. In the other day, you're drawing 2 FBDs. You guys are not wrong, but I'm saying it is a trap. Exam mein you will do only for the full thing, and you'll get a wrong answer, and then you'll feel like, oh, something went wrong. I'm more worried about that. Clear na, Vihan? You still have to draw 2 FBDs. So, like I'm saying, na, in this case, it works. Because if you say like that, na, then you know what I will do. I'll put 3 blocks. अभी क्या करेंगे? If you say like that, I'm telling you, na, they can play around a lot. Suppose I'll put a pulley here, I'll put a block also. अभी क्या करेंगे? You can mess up the problem in multiple ways. That way. So keep it as simple as possible. Basic level, you should do always from the basics. Next one. We have a block here. Mass M, length L. The left side of the surface is smooth. The right side of the surface is rough. Friction is mu. So the block is exactly on the border. Now someone kick the block with speed U. So assume the block completely enters inside. Find the distance traveled by the block before it stops. Let's get this. This is a good one. What's the catch? When the block is entering, this is the scenario. Let's say some part of the block is inside X. That means only this shaded part ka weight is responsible for the friction, isn't it? Friction on the block is only due to the shaded part. Because only the right part is having friction, only that part is responsible. So meaning the more you enter, more friction you get. Friction is not constant. So how do we do that then? I hope everyone figured out this part. As the block starts entering more and more, the friction will change, friction will increase because more and more surface is becoming rough. So you directly can't say F is equal to mu mg. Think, take a minute. See, then what is the catch here then? The weight you have to take of that part only. So what is the mass of the shaded part? So mass of the shaded part will be the total mass by length into x, agreed? Because for length L, mass is m. For x, the mass is small m, unitary method. You know where we have done this? Remember our rope ka problem? Rope is pulled with F, find the tension. Similar idea there. That means when you draw the free body diagram of this guy, so only this part is having there. So this part is x. So friction would be F is only mu into small m into g. Small m is this guy. It is mu into m by L x g. Acceleration is backward. So F is equal to capital M into. Now understand one thing. Even though friction is only due to that shaded part, mass to will come for the full block. Because the overall block is decelerating. Mu mg x by L is equal to ma. Mm cancels. We get A is equal to mu g by L into x. This is the acceleration of the block while entering. So problem has two parts, while entering and completely entering. Completely enter करने के बाद, that is easy. That is like first problem. Is a constant acceleration आएगा. This is the acceleration while entering. All clear with this? So it is increasing with distance. The more you travel, more deceleration you have. Alright?
Sir, why did we take the whole mass instead of just small m?
Oh, so according to you, this block will be here and the block will become two parts and this will fly away.
No, sir.
तो वही तो है ना, मतलब full mass क्यों लिया, मतलब तो सोच. Do you mean to say these two parts are separated?
No, but the friction.
So, now see, if I pull your
force will be the friction force will be mu small mg, and that we have to divide by capital M to get the acceleration, right?
Of what? Of what?
Of the whole block.
The whole block, मतलब तू ही बोल रहे हो, then whole mass लेना पड़ेगा.
Okay.
So if you mean to say if you pull your right hand, your left hand will be there only, and your body will come.
Yes,
You
sir.
get the point, na?
Yes, sir.
Friction क्या हो रहा है ना? Friction is acting only on this part. But like you said, this force, this both are connected, right? तो पूरा उसमें force है ना? It is like saying I'm pulling your right hand. It doesn't mean only your right hand will come, right? That looks pretty weird. Your whole body will move because they are all connected. ठीक है? Sure, na?
Yes, sir.
So once we got the acceleration, A is equal to mu g by L into x. Remember, it is decelerating. A is minus v dv by dx. How do you know it is decelerating? Obviously, speed is forward, acceleration is backward. This you have to be careful. Whenever you know the systems are decelerating, it's minus if A and V are opposite. So minus v dv by dx. Kinematics, everyone. Integrate. Calculus. Minus mu g by L x dx. This will go from 0 to L. When the block completely enters, length is L. and the speed will be from initial speed is u to v. So we get v square minus u square by 2 is equal to minus mu g by L. That is x square by 2. The limits will be L square by 2. So v square will be u square minus mu g L. Now be careful. What is this v? This v is the speed of the block when it has just completely entered. The block has completely entered the rough surface. Then the speed is v. Just after completely entering. Now if you're completely entered, now we have to draw a new FBD. Now what will be the friction? Now friction will be maximum, right? Because it is skidding. It will be mu capital mg. This is the acceleration. So F max is equal to ma. The mu mg is equal to ma. Now the acceleration is constant. Is that making sense? Once you've completely gone inside, friction will be full weight. So now the problem has become like this. So your block speed is v. So you will travel some distance and stop. This distance is s. So v square minus u square is 2as. So here your final speed is 0 square. V square is 2. Acceleration is minus mu g into s. V square is how much? Minus minus chala jayega. U square minus mu g L is 2 mu g s. S will be mu square by 2 mu g minus L by 2. What is this S? This is the distance traveled on the rough surface. So total कितना travel किया? First you traveled L here and then you traveled S here, na? I hope you're getting. The question is total distance traveled. So this block here, if I draw the diagram, initially you're here. This is L. The rough surface started from here. Then you entered completely here. इस टाइम में आपका speed v था. This was u. And then you travel somewhere till here. And then you came to rest. This was the whole scenario. The problem has two parts. So if you try to measure the distance from here, this part has gone here. So point A is here, point A is here. So this was L. Then point A is here, this was S. So total distance is L plus S. And S is what? U square by 2g L by 2. So U square by 2 mu g plus L by 2. Is this clear, everyone? So you traveled L distance on the smooth surface and S distance on the rough surface. So the problem, you have to do it in two parts. While entering, after entering. After entering is easy. While entering is the headache. Step 1, free body diagram, equation, friction, kinematics, calculus, everything is there. This would be an advanced problem. For you guys, it is hard, but when you're in 12th, this will be an easy question advanced level. Because you become strong by then. Is this clear, everyone? Any doubts? Anyone? See, this is how you should analyze part by part. Don't always think like, yeah, problem ka answer nikalna hai. The moment you get obsessed with the answer, you'll stop thinking. That's what I keep telling. You know, the only time you need to think about marks is while writing the exam. Once the exam is over, focus on your subject. Marks are a byproduct, eventuality. They'll eventually come once your subject is strong enough. Clear with this? Next one. Let's get this thing. So we have two spheres, R and small r, and there is a rod of mass and they're lying like this. Question is, find the ratio of r by r so that the rod will not slide. Meaning there is a possibility rod ऐसा हो जाएगा. Isn't it? Can slide na, like an incline. Try 2 minutes. Question is easy. The physics part is easy. Headache is the mathematical calculations. That's what I'm saying. Just because the calculations are lengthy, don't think the problem is tough. So I'll show you what do you mean by tough problem. Lengthy problems are different, tough problems are different. This is an easy one, but lengthy to solve.
Where do we get a good ratio?
ये क्या है यार? बताओ क्या है यार? कुछ तो आया होगा ना? टेल ना. Why are you hesitating?
I'll send in the chat.
Root आएगा. Did you get a root?
नहीं, fraction.
Then गया तो. Fraction होगा, उसमें root भी होगा. Let's see. Step 1, choose the system, draw the FBD. Story is always the same. So if I extend this like this would be theta. It's kind of like an incline. So if you look at the forces here, this guy would be mg sine theta. This guy would be mg cos theta. This guy would be the normal reaction, let's call it N2, coming from the center. This guy again from the center, normal reaction N1. Every point in contact will have a normal reaction. Now, if there is no friction, the rod will slide downward. So friction should be upward. Since there are two contacts, there will be two frictions, F1 and F2. Bus, that is your free body diagram. He said system is in equilibrium, and the question is saying minimum value. That means the rod is on the verge of slipping. Since we want to find minimum, the rod is on the verge of slipping. So we can say F1 and F2 are maximum. So that's what I'm saying. You need to make an argument and prove that it is about to slip. Therefore, rod is on the verge of slipping. Now, without this statement, without telling this statement to yourself when you're at F1 max, F2 max, luckily sometimes you'll survive. Most of the times you'll get slaughtered. It's like crossing the road with your eyes closed. Once in a while, you'll survive. You do that repeatedly 10, 15 times, the car is going to hit you. Therefore, F1 and F2 are max. You're done. So N1 plus N2 is mg cos theta. F1 plus F2 is mg sin theta. Friction is mu into N1 plus mu into N2 is mg sin theta. This is what I said. Physics part is easy. N1 plus N2 is mg cos theta. Done. We got tan theta is equal to mu. But I didn't ask you this. I asked you R by R. Clear? Now what? Now I can just draw the circle. Now it's more of a geometry. This is theta. Now be careful. This is 90 degrees. It's a tangent, now. This is 90 degrees. So from here, if I drop line like this, if that is theta and this is theta, this length will be r minus r. This will be r and this will be smaller. So that is r plus r. So we got a triangle like this, 90, where this is r minus r and this is r plus r and this is theta. That is opposite side. Sine theta is opposite side r minus r by hypotenuse r plus r. Now you can simplify. What is this? And then, but we already know tan theta is equal to mu. We know how to get tan theta as a sine theta. So this is theta, this is mu 1, and this is root over mu square plus 1. So sine theta is mu by root over mu square plus 1. Cross multiply and finish it off. You'll get an answer here. How much is this? I will leave that to you. That much you can solve. कुछ अच्छा आंसर नहीं आएगा. You will get something like mu minus root over 1 plus mu square by mu plus root over 1 plus something like that. I remember. Plus by mu minus. ऐसा कुछ आना चाहिए. I think Pratik, you got it.
Sir, I got the ultra of it. मतलब plus sign नीचे minus sign ऊपर.
नहीं ना रे, r should be bigger than small r ना रे.
But it is we have to find a small r by capital R का ratio ना. We have taken it ultra.
हाँ ठीक है ना, चलेगा. Same thing. Something like this you will get everyone. So check कर लेना. I'm not sure about the answer. Clear? Got
So
the
it is
steps?
1 plus mu square minus mu in the denominator.
ठीक है चलेगा. Trust you guys. This much calculation you can do. Clear with the steps? कितना आ रहा है बता दो, लिख लेते हैं. म्यू प्लस 1 प्लस म्यू स्क्वायर डिनोमिनेटर में.
Denominator में 1 plus mu square का root plus mu. Sorry, minus mu आएगा.
माइनस में. ओके ठीक है. हाँ, something like this you will get. You guys just verify. Clear with this? Easy, right? मतलब tough नहीं था, but you should know.
Previously. Okay, sir. Thank you.
Let's see one more. We have a weird surface like this. On this weird surface, You have a rope. It's a uniform rope, which is on the verge of slipping. Means little push and it will go off. See, whenever you hear the word verge of slipping, means frictions are maximum. So this is mu, this is L, this is H. Do you guys remember we did something like this for tension? Result याद है किसी को? T1 minus T2 is lambda G into delta H, the difference in height. Let's get this. So you kept the rope on some weird surface, height H, length L, and this rope is about to slip. Find the coefficient of friction. Try. Just give it a try. Let some water and come. Let me help you with this. Like I said, these problems, right? You should have seen them once. Seen something like this in NLM. So the idea here is, look at this. If you take any small piece, let's say somewhere in the middle here, take a small piece here, ds. So I can treat this small piece like an incline whose mass is dm, that mass of the ds. So we are taking this length is ds. Now, if you write the forces, this would be dmg sine theta. It is just like a block and an incline, dmg cos theta, normal reaction. And this is F max. Why F max? It is about to slip. Right? Now, if you look at each piece, so on all the pieces, friction will be backward, isn't it? Similar on all the pieces, mg sine theta will be forward. So that means all the frictions on all these pieces must be balancing all the mg's on these pieces. So total friction total frictional force on the rope must be equal to the total component of weight along the string. So all these mg sin theta ka components must be equal to all the friction ka components. Is that, do you guys agree with that? Doesn't this look like net pulling force method? Net force along the string must be equal to mass into acceleration. So it means all these frictions here and all these mg sin theta here are cancelling out. So that means integral all frictions must be equal to integral dmg sin theta. Let's call this df max. It's the friction on that small segment. Any doubts on this page, please ask me. Clear na, Puruja? Surya? Sharman, clear with this? Now, once we got this, so see how it is. All these mg sin thetas I'm showing with green color here. So these are dmg components. They're pushing it down. All these friction components, all the red ones are the friction components. df components are pulling up. So integral df max is equal to integral dmg sin theta. Now for that small piece which we took ds here, if you take this angle to be theta, this horizontal distance is dx, the vertical distance is dy. And mass dm is nothing but lambda, that is a mass per unit length, into ds. We don't know that, it's not given. But let's see what happens, it will get cancelled. So this guy is dmg cos theta. Be careful, don't cancel dm in the integral, you can't do that. Don't say I'll cancel this and this, it's a blunder. That is inside the integral, it should come out. What is dmg? Lambda into ds into g cos theta. Here at every instant, theta is changing. This is lambda ds g sin theta. So lambda and g will come out because they are constants. This is ds cos theta. There is a mu also, no? I forgot. This is a mu also. Lambda g integral ds sin theta. But from here you can see cos theta is dx by ds. Or you can simply write dx is equal to ds cos theta, the adjacent side. Dy is ds sin theta. Substitute here. So lambda g will cancel. Now you can cancel once you're out of the integral. So mu into, this is the integral dx, this is integral dy. So this x ka values will go from 0 to L, height ka values will go from 0 to h. So mu into L is equal to h. Mu is equal to h by L. Independent of the shape. It doesn't matter how it looks. Mu depends only on the height and the L. I'll just show you the final result. Listen to this. I can write it in a more general form. Suppose if you have surface like this, and if you have a rope like this, be careful. This formula is valid only when the rope is about to slip. Uniform rope on the verge of slipping. Then this formula says if this height is h1 and if this height is h2 and if this length is L, the friction mu is given by h1 minus h2 by. Quite a useful result. This is the friction. Works when the rope is about to slip. It doesn't matter what is the shape, it doesn't matter how it looks. Just take the difference in heights and divide by length.
Sir,
Hmm.
sir, why can't we cancel dm in the integral?
Oh, so according to your logic, if I have something like integral x dx is equal to something like, something like x cube dx or something, you'll cancel dx, x and x will cancel. So 1 is equal to integral we cancel kar lena. 1 is equal to x square. So x is equal to plus or minus 1.
No, sir, but we can write that mu dm g cos theta equals to dm g sin theta, then cancel dm before integrating.
Okay, then what will you get? Then you get tan theta is equal to mu.
Sir, I didn't take tan theta. Sir, I put
Mhm.
cos theta equals to dl by ds and sin theta equals to dh by ds. Then I cancelled ds on both sides and then I just integrated.
Can you try to do this when friction is equal to, let's say, mu naught x? Now you can cancel. It is an integral. You cannot cancel until it comes out. You know what you're saying? For example, see, if I have something like 3 plus 2 is equal to some a into 9 plus 4. 3 ones are, 3 threes are, 2 ones are, 2s are. So 1 plus 1 is equal to a into 5. How does this make sense? This is fine. Agree with this? This is how exactly I feel when you cancel the thing inside the integral. You can't say what he is saying, Vihan is saying, why can't I just equate these two? Is that what you're trying to say?
Yes, sir.
Then Vihan, what you're saying every segment ka DMG sin theta is cancelling every segment gets own friction. Is that necessary? What about this part here? When it is flat here, is there any DMG sin theta here? But there is a friction there. If you look at this part here, very steep here, there is more DMG sin theta than friction here. Are you getting this?
Okay, sir.
You cannot say DMG sin theta is not equal to DF max. What the meaning of this statement is, if you say these two are equal, then you're indirectly telling component of each piece, the mg component of each segment need not be equal to friction for that segment.
So they only need to cancel each other out after adding.
There is not necessary they'll cancel out, right?
Yes, sir.
Is that making sense, everyone? Because in this part here, is there anyone pulling the rope here? There is no DMG sin theta there, but friction hai. In this part of the rope, there is a big DMG sin theta, but friction is very less. So that's what I said. There is a difference. Total friction is equal to total weight. So integral, you can equate with integral. If I don't put integral, they're not equal. I hope that is making sense.
Yes, sir.
Right?
So they
Think
are
of like
only
this.
equal when integrated.
Think of like this. Let's say I'm giving you some money and taking some money from you. Okay. So let's say first day 1, I gave you 10 rupees, but I took minus 5 rupees from you. Day 2, I gave you 20 rupees, but I took 10 rupees from you. Day 3, I gave you 5 rupees and let's say I took 20 rupees from you. End of the 3 days, how much did I give you and how much did I take? Net is 0. But does that mean on every day you're getting equal and opposite? I hope you're getting it. The total money given to you is equal to total money taken. But you cannot say on each day I give you the same money and took you the same money. I hope you're getting the analogy. Something similar happens here. On each segment, the friction is not equal to dmg sine theta. But if you add all dmg sine thetas and if you add all frictions, they have to be equal. So if you don't put integral, it is wrong. The moment you put integral, suddenly it becomes right. Clear, Vihan? Is that clear, everyone?
Sir.
Anyone else has a doubt on that? It's a pretty good argument.
Sir, can you just show the next page?
And I hope everyone is getting why I can't cancel dmg inside the integral. Integral dm, आपने अभी तक integration complete नहीं किया. There is an integral waiting there. It has to be done. Then only you can do that. If you say that, I will tell you like this thing. See, if I say integral x square dx is equal to a into integral x cube dx, can I cancel x square and x square here? Then I can cancel dx and dx also, na? Then you'll have one snake symbol here is equal to a into snake symbol into x. What is this? Then we'll cancel the snake symbol also. We get 1 is equal to x. There, hence we proved a is equal to 1 by x. This is how it will look. So don't cancel. That integral is not a bracket. It is a function. It is a operator. Clear with this?
Sir, can you show the next page?
कर क्या रहे हो boss? तो exactly page. Focus
Sir,
na. You
actually,
understood, right?
Sir, actually, I wanted to see this page only.
Okay, you only said next page, so I turned it. अच्छा diagram है ना? I know you should appreciate that. Have a look at it. Let's see how they'll ask the question in the exam. Now, this is one way of asking, but they can frame in another way. Clear with this? So this is the second time you're seeing this question. Something like this. We will not see a result like this. This is only 2 times it will come. Clear? Going ahead. Based on this, the same question, B part. If they have to ask in the exam with some numerical or something, this is one way to ask. Let's say we have a rope on a circle. The rope is like this. This angle is 60. This angle is 30. Rope is about to slip on this circular track. Find mu. So here the shape is little more decent. But like I said, we proved it for a random shape, then it works for everything. Let's get this. It doesn't matter, वो just cancel हो जाएगा. Take, want radius ले लेना. Yeah. So, like I said, once you got the idea, it is just brute force here. So the formula says you want the difference in height. So if this is R, this would be R cos 30. If this is R, then this would be R cos 60. So this would be your height, H2, which is R by 2. This would be your height, H1, which is R cos 30. So I leave it in 30 angles only, R cos 60. But you need also the horizontal distance. This would be R sine 60 and this would be R sine 30. That was your length. So mu will be the difference in height H2 minus H1 by the distance between the 2 points. So that is R cos 30 minus R cos 60 by R sine 30 plus R sine 60. That is root 3 minus 1 by root 3 plus 1. You can further simplify, but okay. You can do that root 3 plus 1, root 3 minus 1, divide and multiply and finish it off. Clear? There, this is how they can frame questions. If you try to do this normally, you can, but again, integration will come. But this result will save you because we proved this for any random shape. But be careful, this is only valid when it is about to slip. Clear? Arnav, Abhinav, clear with this? Arush, got this? Ojas, clear, na?
Sir, so can we say from H2 to H1, if we draw a line along the horizontal, then the angle will be 15 degrees?
हाँ, हो सकता है.
Because 2 minus root 3 is tan 15.
Yeah,
Okay.
ठीक है. That is fine. That is a geometry. Clear, na everyone? Next one. We have an incline. This is theta. This is mu. We have a block M here. It is projected with speed u. The block goes up and comes down to the initial position. Find the ratio of time of ascent by time of descent. How much time will it take to the maximum height, and then how much time will it take to come back? Assume the block never stops. Matlab, you have enough velocity so that the block will not stop. There is a possibility block will just go and get stuck there. We are not taking that case. Even if that is the case, answer will take care of it. Find the ratio of time of ascent by time of descent. How long will it take to go to the highest point, and how long it will take to go from highest to the initial point? I hope the question is clear. You think the answer will be greater than 1? Okay. Let's say the 3 options are greater than 1. Now what? You eliminated 1. Nice. Any answers? Let's see. नहीं इतना अच्छा आंसर नहीं आएगा. Sin theta minus u cos. Didn't you get a root, Moses? Without root, you got the answer. Hmm. Let's see. Ratio is root. It looks like we haven't got it. Let's see. The thing is, while going up, what are the forces? We have mg sine theta. Now, since it is moving, friction is maximum. Mu mg cos theta. So this is your acceleration. So finally, it will go somewhere here and it will stop. Let this distance be s. So here acceleration would be mg sine theta plus mu mg cos theta is equal to m into a1. I'll call it a1. So from here I get a1 is equal to g into sine theta plus mu cos theta. Perfect. So you want to find the time. So v is equal to u plus at. Final velocity is 0. This is u. This is minus a1. This is time of ascent. I'll just call it t1. There. So we get t1 is equal to u by a1. What about the distance traveled? V square minus u square is to as. So final speed 0, u square 2 minus a1 into s. So the distance traveled is u square by 2a1. You will see why you need that. You can't write time of ascent is equal to time of descent. Is this step clear, everyone? Now this block has reached the top and now it starts coming down. Now when this thing starts coming down, mg sine theta is downward. How is the friction? No, friction is up, na? If the block is coming down, friction will be up the incline. Now the acceleration is a2. Acceleration has changed. While going and while coming down, you have different acceleration. Mg sine theta minus mu mg cos theta is equal to ma2. So I get a is equal to g sine theta minus mu cos theta. Now this is the reason I found s. You cannot find the time. When it reaches here, is it at rest? We don't know, right? So it has some velocity v dash, which we don't know. So you can't write v is equal to u plus at. यहाँ पे कैसा हो गया ना? Luckily, it stopped here. So v was 0. So you wrote this and you got the time. Here you can't write v is equal to u plus at because you don't know it is going to stop. You're getting it? So there is no way you can find out that. So we need to find s. So we will use s is equal to ut plus half at square. So s is that same as u is 0. Acceleration is half a2. This is the t2 square, time of descent. And what is s? S is this guy, u square by 2a1. Is half a2 t2 square. So from here we get t2 is equal to u by root a1 a2. This is the time of descent. So time of ascent by time of descent. This guy is u by a1 by u by root over a1 a2. So this is root over a2 by a1, which is root over sine theta minus mu cos theta by sine theta plus mu cos theta. Check. So the problem here is we don't know the final velocity. So I can't use v is equal to u plus at. That's what makes this problem a mess. You had to find the distance here. Please have a look at the steps. It's not difficult, but you have to be careful. It's like just brute force solving. Is this clear? Clear, everyone? Next one. Any doubts on this page?
Can you show the previous page?
Hmm.
Okay, sir, thank you.
Clear, na? Next one. Clear, na, Adi? Clear? Nikhil? Vignajit? Pratik? Surya? Niharika? Clear? Going ahead, Devansh? (45 degrees). Let's say is equal to mu is equal to half, and let's say this is 10√2 kg. So we have a pulley here and we have a block M. Find M if the system is in equilibrium. One thing I'll tell you, see, remember this, whenever you hear the word friction and equilibrium, it's a trap. Keep that in mind. I'm telling you now, you hear the word friction and equilibrium, you should be scared. Let's try. You guys do it, I'm just saying. Now, right now, don't be scared. After I give you the answer, you can be scared. It's not nothing big, it is just a small thing, but yeah. This problem will really show you why friction is a rogue. Let's go. 2 minutes. We have different answers. Like I said, we have 1 kg. That is weird. We have 15 kg. That is fine. 5 kg. Someone got 5 and 15. Someone got 1.5 and 0.5. 1.5 नहीं है gods. आप g का वैल्यू नहीं ले रहे हो क्या? You forgot to take g का वैल्यू. और एक जगह g लिया, दूसरी जगह g नहीं लिया. Something you did. So most of you who got 5 and 15, right? You are not wrong, but you're incomplete. Right, Poroja, you figured it out. So how many answers are there? There are infinite answers. Listen. What happens here? Imagine you put too much weight. You kept a lot of mass. You keep a very heavy weight, then the block will try to go up. So if you look at your FBD, this is the tension. The block is trying to go up. This is your mg sine theta, which is 100. Your friction also will be backward F max because you're about to slip. This tension here, this is tension, this is mg. So from here we can see tension will be mg sine theta plus mu mg cos theta. M is 10 root 2, sine theta is 45, so that sine theta and 45 will cancel off. You will end up with this is 100 and this guy is 50. So F max is 50 newtons. So we know T is equal to mg, so we get M is equal to 15 kg. This is the maximum value. Anything more than this, the block will go up. Suppose if you keep very lightweight, M is minimum, then the block will try to slide down. Then if you draw the free body diagram, this is tension. This is mg sine theta, which is 100. This time the friction is upward, which is 50. This is tension, this is mg. Same story. Tension would be mg sine theta minus F max, which is 50. But we also know T is equal to mg. We get M minimum is 5 kg. Anything less than 5 kg, the block will slide down. Now, listen. I'll come back to this page, but let's try to understand here. Here, the system is fighting between two forces here. This is your mg sine theta, which is 100. Now, this is your tension. You can keep changing the values here. Now, you tell me, suppose if the tension ka value T is 100, what will be the value of friction? 0, right? If the system can be in equilibrium, why should I come and mess it up? Understand one thing. What is the job of friction? Is it to give full value? Is the job of friction to give full value? No. My job as a friction is to make sure body is not slipping. If the tension can somehow balance mg sine theta, why should I come? Agreed? Let's say the block weight is a little less. Tension is 90 newtons. Now, how much will I give? I will give friction 10 in the upward direction. Do you agree? Again, what is my job? My job is to stop you from slipping. What if tension is 60 newtons? Then how much will I give? Friction will give you 40. What if my tension is 15 newtons? Then I will give you maximum value 50. You're getting it? Depending on how much mass you keep on the right hand side, friction will adjust its value. Friction will not always give 50. Suppose if you give more, let's say tension is 110. Now what will happen? Now friction will reverse the direction and it will give only 10. Can you see what is happening? Depending on how much mass you're keeping on the right hand side, friction will adjust the direction, friction will adjust the magnitude. Suppose if T is 130, then friction will act down and give 30. If tension is 150, then friction will say, boss, I'll give you a maximum that is 50 in this way. Is this making sense, everyone? So friction doesn't have a constant value. Depending on value of small m, friction can give anywhere from plus 50 to minus 50. Therefore, if you look at here, the final answer for this, the mass m, it lies between 15 kg to 5 kg. Any value between this, the friction can keep it at rest. So exam में they'll give options like this. What is the value of M if the system is in equilibrium? Options will be 3 kg, 7 kg, 9 kg, 13 kg. They'll give like this. And if it's a more than one choice question, you have to mark all the three answers. Most people will get 5 or 15. Some people will get 10 also. But what you forget is it's a range. So that is that thing. Always remember, whenever you hear the word friction and equilibrium, there is always a range. You don't have a single answer. You get infinite answers. What you're finding is the extreme cases. Everything in the middle is acceptable. Like this. This is what I was saying. Friction can adjust its magnitude. Friction can adjust its direction. It can do both. Is this clear, everyone? Anyone not convinced with this, please ask me. It's a good problem. This you'll again encounter in other chapters. Next one. Any doubts? Anyone not clear with this part, please ask. Adi, clear with this? Ansh? Daksha? Clear? Jainil? Sharman, clear with this? Next one. The next one is another standard question. You need to mug up this result. Means bits में direct question है. We have a block of mass and friction is mu. Find the minimum force required to move the block. Anyone got an easy answer? UMG करके feeling आ रहा है? That will be there in the option and that will give you -1. I'll give you a hint. See, did I ever tell you the force is horizontal? That is how it is. Who told you need to apply horizontally? So start like this. Apply a force F at an angle theta. So for different thetas, you get different forces. I'll tell you the reason. See, when you apply F at an angle, there'll be a vertical component F sine theta. Because of that, normal reaction will decrease. Because of that, friction will decrease. Na? You're getting it. There are two ways to defeat an enemy. Right? You can become stronger than him or you can make him weaker. So here our force is trying to decrease the normal reaction and therefore decrease the friction ka value. And the F sine theta is anyway trying to overcome it, F cos theta. So you can use some part of your force to decrease the normal reaction, which will in turn decrease the friction ka magnitude. So instead of using all your force just to go against friction, why don't you use some of it to destroy the friction ka magnitude? So start like that. Let the force be at an angle theta. Then you get force as a function of theta. Then you have to do maxima minima or trigonometry. Puroja, but theta is not given. Try. I'll give you a minute or two. This result, you should definitely mug it up. We'll put a star for this. Mains or bits, it's a direct question. So let this force be F. F cos theta, F sine theta, our own weight mg, normal reaction. This is F max since the block is about to slip. Since you said the minimum force to move the block means it's about to slip, right, Niharika? So from here we get the normal reaction is mg minus F sine theta. And here F cos theta is F max. So F cos theta is mu into N, which is mu into mg minus F sine theta. So from here we get F is equal to mu mg by cos theta plus mu sine theta. So to make it minimum, we need to maximize this. Maximize denominator for F minimum. You have seen something like this, in kinematics. Remember man crossing the road. And we know from trigonometry, if you have a sine theta plus b cos theta, the value is always less than equal to root over a square plus b square. Therefore, the minimum force will occur when the denominator becomes mu mg by root over 1 plus mu square. If you look at this, this is definitely less than mu mg. This is a result. You should definitely mark it up. Clear? So there's a theoretical question like this, which is easy. Is pulling easy or pushing easy? Now, from this
Sir,
diagram, if you look at this,
Sir, could we also just do df by d theta and then find
you
out?
can do that. Yeah, you can do that.
Okay, sir.
वो थोड़ा लंबा जाएगा. You'll do that, you'll get theta, then you'll substitute, you will get it. Instead of doing df by d theta, why didn't you just differentiate this thing only, na? So, same thing, if you take a block here, and if you push with F, if you take the block here, and if you push with F, the difference in both the cases is, this would be your F sine theta, this would be your F sine theta. So in this case, the normal reaction would be mg minus F sine theta. In this case, your normal reaction will be mg plus F sine theta. So friction becomes more in the second case. So whenever you want to pull something, pulling, whenever you want to move something, pulling is easier than pushing. Next time, observe this. If you have a very heavy, last time whenever you pulled something really heavy, rice bag or some stool or something, you always dragged it. इतना कि movies में कभी देखा? Hero kills the villain and drags his dead body. He never pushes the dead body. Right? So hero is like this. The villain is there on the ground like this. And this guy is dragging the dead body and going. So you're able to visualize. Pulling is more easy. Clear with this? Put it on. So that's the last one for the day. So next class, when we catch up, we are going to do a little more. We are going to do something called angle of repose, and then we'll do a few more models. And then we will see, we will go for 2 block problems also. That is the most important one. We should be able to wrap up in the next 1 or 2 classes. I hope you can see the difference, right? The chapter completely looks like kind of like NLM only, right? The only thing is friction ka direction and magnitude. As long as you know that, the questions go. Okay, so with that, we'll wrap up for the day. So do resolve the paper last week. We will discuss that paper on Thursday. As usual, we'll do the discussion on Thursday. So any doubts in today's class? We have done almost 10 questions. I think you can start doing booklet or whatever. In case you have not started friction, right? You can start doing now. You'll be able to handle questions. We have done the basics. You got the basic idea there. But we will do more varieties in the next class. Okay, so those are out, stay back. Others are free to leave. So any doubts in today's class? Anything?